Hello everyone, you're watching AWS and Machine Learning, and the current topic for this lecture is data types and data transformations for machine learning. And this is part two. If you haven't watched the lecture number 21 of the series, please go to lecture number 21 before you move on into this lecture. So my name is Shinaz Malik and I'm a data scientist, and let's move on and then see what we have been doing until now. So now we are going to learn about orthogonal sparse bigram transformation, and just to give a quick recap, we are talking about data types and data transformations, and we have been talking in last lecture. We reached to the text variables, and you see we have already seen n-gram transformation, and now let's understand orthogonal sparse bigram transformation. Okay, let's move forward. So let me put it crisp and clear to the point. So OSB transformation is intended to aid in text string analysis and is an alternative to bigram transformation. A bigram is another name, in ngram with a window 2, with a window size 2, is also known as bigram. Okay, so don't get confused if I'm saying bigram. Bigram is just another name when we have ngram with window size 2. Okay, uh, OSBs are generated by sliding the window of size n over the text, okay, and outputting every pair of words that includes the first word in the window. Uh, I will give you an example, uh, show this. So let's first understand it. So to build each OSB, it constitutes words are joined by the underscore character. And every skipped token is indicated by adding another underscore in the OSB. Thus, the OSB encodes not just the tokens seen within a window, but also an indication of number of tokens skipped within that same window. So let's see an example to understand what we have just now, read. To illustrate this, let's consider a string. We all know that a quick brown fox jumps over the lazy dog, okay, and OSB of size 4. Now, six 4-word windows, and the last two shorter windows from the end of the string are shown in the following example. As well, OBS generated for each. Now, if you see window, okay, and OBS generated, this is just apologies. So, okay, so the quick brown fox, okay, if you this is your text, so what will happen if you see uh, the and then there will be underscore, okay, because the quick is the first, after the day, first word after the. So if you see, so we are using this one space is converted by this one underscore, and then if you see the brown, so between brown and there are two white spaces, so we will show each white space will be by one underscore. So if you see the distance here, there are two underscores because you see one space is here between the and quick, and there's another space between between brown and this. So this space and this space is designated by under two underscores. So it's showing us that brown is two underscores away from the, and so on. And if you see the fox, the underscore three times underscore fox. So if you see this underscore, and this underscore, these are on three underscores. So this basically, shows us the distance uh, between the two combined words, and if you see same is here. So the quick brown, okay, quick fox, and so on. So if you understand this, this, if you understand this, that's wonderful. That's wonderful to know. Let's move on quickly. So orthogonal sparse bigrams are an alternative for n-grams that might work better in some situations. So if your data has large text fields, 10 or more words, experiment to see which works better for your problem in hand, and move on accordingly. And I have to, I have to say it, and I will be repeating it. Data science is not all about methods. It's about working smart, being creative, and some cases to experiment and see which one works your data and the problem in hand. So please note that what constitutes a large text field may vary depending on the situation. However, with larger text fields, OSBs have been empirically shown to uniquely represent the text due to the spatial skip symbol, the underscore. Just remember this, and you can request a window size of 2 to 10 for OSB transformations on input text variables, and to compute OSBs with the window size 5, for example, for a variable var1. You could show like this, OSB, and then bracket start variable 1, or var1, comma 5. So and that's it. It's simple, to the point. I will be showing you in the projects, in when we take different projects, how to implement these things in future lectures. Just stay connected with me, and in the meanwhile, this is time to say, if you like my videos, please subscribe if you haven't until now, and please hit the notification bell so that you get notified as soon as I upload new videos. I hope to see all of you in a next video. Thank you all for watching Data Analytics Professional. Remember, sharing is caring, and don't forget to share this video with all your friends and families. And it's time to say goodbye. Thank you.